Hi, everybody. So you are in this talk to talk about, this is called Running with Droplets, the Cost of Cloud RTC. And what we're going to discuss today is a little bit about like co-location data centers versus cloud hosting costs and some of the tools you can use to accomplish sort of both of those in a hybrid approach. And also kind of the reasons why you might want to do that. I know people here probably have a lot of experience with this. Maybe some do, maybe some don't. So we'll kind of walk through it a little bit, and if you have any questions or anybody has any comments, like it's the start of the conference, so let's keep the energy high. By the way, I am Evan McGee. I'm the CTO and one of the co-founders of SignalWire with Anthony Menesale and Sean Heine. We do a lot of this in our company right now. We do a lot of this sort of hybrid colo plus cloud approach to running our business. So we have a lot of experience doing that. I've been doing it for a long time. Sort of what my specialty is, and it's a lot of fun. So I would recommend it. It can keep you awake at night, and that's why you need that sort of red shifting application, right? Anyway, show of hands here. So who here, show of hands, who here runs their own data center? Who here has their own data center, right? All right, yeah, that's pretty good, right? Who here has their own cloud deployment as well? Run stuff in the cloud. Great, not as many as should, but that's cool. And who here does both? Who has their own data center, but also cloud deployments of everything else? All right, look around. So notice there's not that many people who have their hands up, right? There's only like, a good 10, maybe 12 people who do that. So what we're going to talk about here is really why that is probably the right approach. And if you're not doing that today, you should start thinking about it, because there are benefits to both of these situations that really can make your life a lot easier and your business scale faster and just make your nights like more restful. I guarantee you, your nights will be more restful. I one time sat in the Orlando airport for 5 hours trying to fix a data center outage while my family went off to go see manatees on the coast. And that was the day that I finally really came to light that like things should not be always in a data center. You shouldn't have to deal with that. You shouldn't have to deal with white glove service. You shouldn't have to deal with somebody not showing up to work and having to fix all your own problems. Or if you do, that there's a CapEx involved, and you can handle that. But you can probably lower that. Anyway, let's talk about some of the primary cost drivers when you move things to the cloud, right? These are the things everybody talks about. The cost of bandwidth, the cost of storage, and the cost of compute. These are the number one, number two, and number three things you're going to deal with, particularly in real-time communications, right? Bandwidth is the one thing that we use probably more than anybody else, particularly if you're doing WebRTC video. You're going to be pumping a lot of bandwidth, right? That's a major cost driver to throwing things in the cloud. And one of the things that stops everybody is saying, I can do this cheaper myself. I can put it in my own iron, and it'll be a lot cheaper. And the answer is, yeah, it might be a lot cheaper, but there are a lot of trade-offs here. And also, is your entire stack necessary to run on that iron? Do you have to run everything yourself? Like, there are some pieces that make sense, and there are some pieces that makes no sense at all. So with bandwidth, right, we're all used to sort of the co-located model with 95 percentile billing, where effectively you get a set pipe of 100 megabits second or whatever you want, and then you kind of pay for burstable usage, right? You can pump a lot of data through that. I think it's like 33 terabytes a month that kind of comes out to, something along those lines. And the cloud, here are the recent cloud costs for all the providers, right? GCP is 12 cents a gigabyte. DigitalOcean is a bit different. We'll come back to them. AWS and Azure are trying to get a little bit of a price war there. It's like, great, guys, thanks for that extra 0.003 off. Really sweet of you. DigitalOcean is a bit more interesting in this regard. They give you a terabyte free versus like a gigabyte or 5 gigabytes in the other ones. It's only 1 cent then per gigabyte after that. So you're like, OK, that's interesting. Like it's 12 times cheaper than Google. What are you trading off there? Well, their network is not known for being like the absolute best, but that's kind of just marketing, right? I've talked to those engineers over there. They would claim it's the best. I've used DigitalOcean extensively. I've never really had a big problem with it, particularly recently. And one interesting thing about their billing model is that all of their costs are pooled. So on DigitalOcean, you can actually have, let's say you're running 35 VMs. Each one gets a terabyte of bandwidth. That 35 terabytes is spread out over all of them. So if one of them uses 30 and the rest of them just use 5, that's still a zero cost for you. So it's a really aggressively consumer-friendly business model. So DigitalOcean, when it comes to bandwidth, is sort of the game changer right now, and everyone else is sort of trying to basically make a lot of money on that. And what's interesting too is keep in mind that this is for outbound only. So all of these cloud providers, you don't pay a single dime for inbound traffic. So if you're taking a lot of inbound traffic but not pumping a lot out, that's all free. It's all free to send inbound. And on DigitalOcean, you can send between droplets in a private network for free. In Google and Azure and AWS, you can send within the same data region zone for free, but any kind of external access to the internet is about 12 cents gigabytes. So that can add up pretty quick. So you got to think about it. Well, let's say, what would you want to put in the cloud then? What would you want to put in your colo? things that use a lot of inbound bandwidth. Let's say you're running like a giant Kafka queue, right? Kafka is if no one knows what Kafka is, it's a giant like event, what is it, not an event thing, it's a, like a message queue sort of. Basically, you're pumping a lot of data into it and you're processing it later. But you're pumping a lot of data in, that's the whole point. Like you're just shoving a lot into it and then you're processing it in place and taking some out. That's a great example of something that you could run maybe in the cloud because all of that data input is free. You're just dumping things in there for free, processing it internally, and generating maybe it's like some report or metric that you pump out once. So that's a great example to run it up. You don't need to run that yourself. But if you're co-locating something like, let's say you're doing, again, WebRTC conferencing, right? That might be something you want to co-locate a little bit because the inbound, outbound on that's very, very high. Storage, similar thing right here, right? Roughly it's about 150 per terabyte for an SSD these days. And the cloud costs are pretty much all the same in that regard. But when it comes to storage, there's another thing. Like, if you want to have your own storage array locally in your data center, that's totally cool. That's fun. Like, you need that for something. But really, like, what about your disaster recovery scenarios? What about your high availability? Like, there's a lot there you got to deal with. You're setting up your own Ceph cluster. Like, there's a lot of operational complexity there that I think we've all had to deal with that really like just goes away when you throw things off into the cloud. And it's really not that as expensive as you think, particularly if you build the cost of these services into your underlying business model, or if you can find a way to justify those costs. Like that's the important part, is to think about these not as like, oh God, I have to pay these things, but no, these are just the cost of like doing your business and figuring out how to factor this in. Storage in particular, I would highly recommend, if you're not doing it now, throwing that up there. There are a bunch of different kinds of storage too. There is like blob storage, right? Object storage like S3 and those kind of things where you just kind of throw stuff up. It can be globally accessible. Tag everything as a UUID, stuff it in S3. It's unguessable. It's all secure at rest. I mean, these are some things as well, right? Everything's encrypted at rest. You're not dealing with any kind of physical security break-in scenarios. There's also nearline and cold storage. If you've seen, again, like Amazon's model of they have like slightly infrequent access and then Glacier, just progressively cheaper. And then if you want some sort of extremely fast, volatile memory, a lot of these now have NVMe as a backing store for your VMs. So what you can do is, let's say you want to run like your database up there, you can put that on an NVMe-backed VM, so the IOPS on that are super duper high. Now that's going to come with the fact that volatility is if that VM goes down, that is going to explode and go away. So that comes with some DevOps complexity I'll talk about later. But assuming that you have all your stuff architected correctly, you should be able to lose even your primary database and just keep moving. Right? This is one of the reasons why moving to the cloud is kind of fun, because you can just do that. You can spin up a brand new database with a new NVMe back in like 30 seconds and be back in business. Last one is really compute, right? This is the third one. So compute here is another one everyone kind of hops on for being just brutally expensive. And yeah, for sure, it's like it is totally kind of like it's very expensive, particularly in the long run. This is just some prices I looked at the other day, $5,000 for about a 14-core, 64 RAM Dell machine. I'm not going to include like switches, UPSs, all the other stuff that goes into a normal rack. Like these are just one-time fixed costs. It's not that big of a deal. The CapEx on that's pretty low. And the OpEx on the cloud stuff is a lot higher, right? So now I'm comparing here all these compute optimized things. It turns out that when we did some tests internally at SignalWire, the DigitalOcean Compute Optimized was the same as the GCP Standard Edition, which was the same as the AWS Compute Optimized. And they all kind of performed roughly equivalently. So you can actually compare. These are kind of almost apples to apples comparison, which is nice. So again, 14 times 64 at GCP is about $400, 320. You can see the AWS and Azure are actually like considerably more expensive for like 2 extra cores. They don't exactly all match because they don't have the exact same specs available, but that's kind of the rough cost for those size machines. And that's expensive, right? 10 months, 12 months, you're basically at the price of having your own server. And I know you're going to talk to somebody who eventually is like, oh, but I can just buy my own gear for that. Like, I can have my own stuff. And the answer is, yeah, but do you need it? You might. But if you don't, these guys handle it all for you. The machines go down. The VMs transparently move around. Like, you just eliminate the entire part of your organization that has to deal with physical outages. And you might say, I haven't had a physical outage in 4 or 5 years. It's never going to happen. Until the day it happens. And if you have like a 99.95 SLA, suddenly you're out for 12 hours because of even the data center lost power. Funny story that happened to the last company I was at happened when Hurricane Sandy came through New York. We had a data center in downtown Manhattan. I thought, surely Manhattan will never go under, we'll never run out of power. And these guys at our data center were great, but they were carrying gasoline up the stairs to keep that thing running. But the whole island lost connectivity. And so that was, a real tragedy. So don't assume it won't happen to you, even with all of your best efforts. Because we all know there are soft costs involved in all this stuff, right? Both these things have soft costs involved. The co-location is, you need to have on-site employees or someone there to handle outages or problems when they occur, either white gloves or not. There's fixed hardware if you have let's say your business shifts or you get a big contract or influx of business one way or another, harder to shift, you got to buy new things, provision new things. Much easier to do in the cloud. Conversely, the cloud, the soft costs of the DevOps is a lot higher. You do have to deal with all of these virtual machines floating around and turning up and down. And as I'm going to say, you probably want to spread across multiple cloud providers. So that's kind of what I want to get to here is that those costs we saw before are great. Like, people tend to get locked into a single vendor. You might go to AWS because you want to use Lambda functions or everything else that they offer, but you might go, oh, okay, well then I'll just use AWS for all sorts of things. And I think the right answer to that is don't do that. Don't get locked into a single vendor. We're at the age now, we're at a time where you can just literally use pieces of each single one of these cloud providers for exactly what they're good for. DigitalOcean is great for bandwidth. Google is actually great for compute. Their compute, I didn't mention, their IOPS were about 50% higher. Their base IOPS were about 50% higher than everybody else combined. So, I mean, not combined, but everyone else like in aggregate. So let's say Google was like 12,000, DDO was like 8,000, AWS was like 5,000. So you want to use them for what they're good for, right? And the same thing with your own data center. You want to use it what it's good for, maybe only one specific thing. And so that's the answer, right? What's the answer? That's the answer. Use them all wisely, and don't get locked in. Don't think just because you know AWS and that sort of weird interface they use, that that's your only option. Go learn GCP, look at DigitalOcean, figure out which one works for you from a cost basis. And then start using one of these tools. I've talked about this here before, and I'll talk about them again just very quickly. Who here actually uses Kubernetes? Anyone? Okay, yeah, we got someone. There we go, good for you. Anyone use Docker? Who uses Docker at least? Anyone? Great. Not enough. Who uses Docker Swarm? Anyone? Hey, really? We should talk later. I know not enough Swarm people in this world. Give you a quick background on these guys, right? Kubernetes these are, it's referred to as K8s on the internet. If you ever see that, it's K8s. It was released in 2014. It's actually a descendant from the Google Borg project. It's what they use to control their internal containers for all those years of Google to scale everything. And it's now one of the founding projects of the Cloud Native Computing Foundation, which is a great open source initiative to forward all of these projects. It is a very feature-rich application, right? Kubernetes does a lot. It's basically the equivalent of like OpenStack, if anyone's used that. And if you have used OpenStack, you should be shuddering a little bit. You're like, oh God, using OpenStack was not the greatest joy in the world when it first came out. Kubernetes is a lot better than that, but it's very, very verbose. It requires a bit of setup. It's known to be complex to set up initially. An outline of sort of how it works is this, right? You have effectively like an API server that talks to a bunch of internal stuff, like in the manager over there, and then goes down to each one of those is a node. Effectively, here is like a physical machine or a VM somewhere. They run kubelet, which is the thing that controls everything, cAdvisor, which just monitors stats of the machine, and kubeproxy, and that's the sort of networking component that allows you to talk to all the machines and allows things like ingress networks, which is like if you have, let's say, 35 virtual machines, any one of them can be, let's say you open up port 443 for your web server, any single one of those can be addressed, and it will automatically route to the correct node. That's all handled by the kubeproxy. And inside that, you have the idea of pods, which are actually services and containers. They have their own lingo for this that I'm not as big of a fan of. I think it's complex because it's descendant from a complex system. But it does do there's a lot of functionality and features in that. Swarm is a bit simpler to get started with, and I think a little bit lighter. So Swarm was released in about 2016. It was built internally. It kind of came in stages. Designed by Docker, Incorporated, right? And it's now part of an open source project called Moby, and I won't get into like what that all is, but effectively Docker externalized all of their container and like Swarm and everything development into a separate foundation called Moby, and that handles all of the actual underlying Linux infra like development, and they kind of feed that back into their actual product. It is a much simpler thing with a much narrower feature set. But with that simplicity comes the trade-off of just like it's very, very easy to grok immediately. You can get it started with like 3 lines. Like you can literally start up a cluster with like 2 or 3 lines. And if you Google me, if you Google Evan and Docker, you will see a talk I gave a couple years ago about that actually walks you through exactly how to set up your own cluster. And it's like 3 slides long, and the talk was done. It's a lot of time for question and answer. So it's got, it uses very simple YAML files. It's really a good time. It's all built into the Docker engine, so there's no external dependencies. You saw in Kubernetes there were like 3 or 4 services running per node. You had to keep going. This is just one. You just install Docker, and everything's built in. To zoom in on this real fast, it uses a bit of a simpler model as well as all those things. You basically have your worker nodes, which are just Docker's running, and a couple managers up top that do it. They use a Raft consensus to make sure everything's in order. They use the gossip protocol to actually talk amongst each other. But that's kind of it, right? Everything just kind of talks. It has the same sort of thing that Kubernetes does, where you can have a bunch of nodes. They all talk to each other. One port maps to all of them. It's a very lightweight orchestration layer. And why I like this one for like a hybrid deployment is because let's say you're running some of your compute on GCP, and then you're running some of your, let's say like like inbound traffic on DigitalOcean and everything else. You can make like a swarm or a Kubernetes cluster that spans all of these, because it uses a concept known as an overlay network. And what that is, very briefly, is the idea that you're effectively taking every node in this swarm or in this cluster and linking them all together like in a virtual cloud of yourself. You're basically taking a higher level above the existing cloud infrastructure and putting your own cloud on top of it that spans across all of them. So suddenly you're using droplets and containers from all over the world and all over the cloud landscape to create your own little private cloud that does exactly what you want to do. And that's why these are great. So suddenly you have your own meta cloud on top of an existing cloud infrastructure, and that's a very powerful concept. So this all sounds great, right, Evan? Like this sounds, you're really extolling this. It sounds awesome. Yeah. What's the catch here? There's got to be a catch. There's always a catch. Well, it does involve a very different way of thinking. So if you come from the world of doing virtual machines only, this requires a very, very different set of skills to think about, because suddenly your idea of okay, well, I'm running on multiple providers at once. Everything's in containers and not on VMs. If you're using a Swarm or Kubernetes, you're kind of assuming things are stateless and can come up and down and scale whenever you want. So you got to also assume that you're working globally at this point, right? You got to assume that you're not just have one data center running on the East Coast or the West Coast. You might want to expand into Europe. You might want to expand into Asia or South America. How are you going to locate these things? Things are going to be located physically differently. Maybe you don't want your Kafka cluster that's doing all of this, great sucking up of data to be, 500 milliseconds away from your actual front end. You have to assume these resources are always ephemeral. They might go up or down without you wanting them to, right? You have to, you're not going to have necessarily something that just sits there and is always running and you never touch it and you deploy once every 3 months or once a quarter. You're going to hopefully be cycling these things through all the time. The idea of this is also to enable yourself to do a lot of CI/CD, so you can constantly be updating your applications, constantly updating your services to provide a better value for your customers. And also security. This is kind of a big one that people don't really realize, is that overlay network I was talking about, when you span things across these clouds, you are sending traffic over the public internet between your meta cloud, between a container and GCE over to DigitalOcean or Azure. That's all in the clear, right? There's no encryption there by default. So suddenly you're oh, everything you might think you were transmitting internally in a data center is now externalized, and there's security concerns involved in that you should really take into consideration. With the global one, like I was saying, you're going to need to distribute your stuff around. You're going to have things in Europe, you're going to have things in America. You're going to want to be able to figure out how to scale and move these around. That helps. You also have to deal with different holiday seasons. Let's say your traffic is spiking because, what was it? There was a holiday in Brazil last week. Something to do, even the guys, even our friends in Brazil who we're working with, had no idea what the holiday actually was for. All they knew is they had the day off and they had to call their moms. That's all they knew. And I was great. So they were this traffic is going to spike on this particular day. And so if we had a data center in South America, you'd be great, well, maybe we need to scale up for that one day because we're expecting a lot more traffic. So it's understanding that sort of regionality across the world is important. It's not just focused entirely on Europe and North America. So here, like I was just saying, the cloud, you're going to want to make sure that everything you're running is as stateless as possible. So this is kind of the breakdown of what you'd want to run in the cloud. Basically, if you have any parts of your application that are stateless, run those up in the cloud, right? They can come up and down and scale as much as you want. Anything that consumes variable amounts of CPU and that sort of thing, let's say you're doing a lot in the morning or at night, you don't want your hardware just idling and sitting there doing nothing, or anything that's scheduled. Again, on the colo, you'd want something that does a constant high CPU burn. If you're doing something that just is constantly thrashing with traffic or monopolizing resources or needs a lot of resources, that's something you might want to put in your own data center. And again, that can be part of this swarm or this cluster. It can be your own data center. You can have your database there. You can have whatever you want there. Put what you think goes in the right spot. Ephemeral resources, again, remember that you can't really control a lot of the hardware. You're getting sort of whatever the virtual providers give you. That can be both a good and a bad thing. A lot of them run Skylake-style equipment now, so that's not that huge of a deal. But you have to do a little bit of metric testing. When you spin up a virtual machine for the first time, make sure that you profile it a little bit to make sure that it is giving you the performance characteristics they say it is. Sometimes these are on shared machines, so shared machines can be taxed by somebody else. So again, a little bit of DevOps here, but you write that test once with Ansible. When the machine spins up, you test it real quick. It checks out or it doesn't check out. You turn it off and on until you find one that works. You're going to need to practice a lot of disaster recovery scenarios. So, I said earlier that moving into the cloud kind of, alleviates you from having to deal with backups and disaster recovery. And that's true to a certain extent, right? A lot of these things will migrate around if a machine dies. But you still have to deal with, let's say, if your database goes down, have your standbys ready. If that connection gets interrupted, you have to make sure you're backing up, let's say, to like S3 as your secure backup. What's nice is that all these things are encrypted at rest. So if you're doing GDPR, things like that, it's all just there for you. You don't have to encrypt your own drives, you have to do anything else like that. But you do have to practice, and you should have basically lots and lots of little versions of everything running around. If you're running just one big primary DB and not like a whole little cluster of a lot of small ones of them, then you're probably looking at a situation where you could have a pretty severe outage. And that's the case with any part of your application. There should never be just one of anything. There should be lots of everything. So again, good point of the cloud, spin up and out on demand. Go as big as you want. Not all those VMs are created equal. Again, the nice thing about having a colo is that you can deal with all of this yourself. You do have the overhead of, again, bare metal and managing your own virtual machine infrastructure. Something I didn't touch on before is that if you do run your own data center, you do, and if you want to spin up containers, virtual machines, you have to deal with all of that all by yourself. Not as much fun as you might think, and you're spending a lot of time dealing with like little complexities or little gotchas. I think anyone who's done this before understands that. And security is kind of the last thing I want to talk about, which is that you got to assume on these machines, right? You're now working in the public. Even if you're in GovCloud or something that's secure like that, you have to assume that you're not really alone on your machine. You have to assume there's some sort of meltdown or Spectre exploit that someone's going to get at you with at some point. Or, as you're transmitting information around, you're going to be transmitting it in the clear. So how do you deal with that? And the answer is just everything has to be encrypted. Just you have to get in the mindset that any information you transmit out of that physical machine must be encrypted. Anything at rest must be encrypted. Just all the things must be encrypted. And what does that practically mean? Well, in Swarm, they have a concept of encrypted tunnels. So on that overlay network I was talking about, you can actually make IPsec point-to-point connections between the Swarm nodes that are encrypted by default. What does that mean in the real world? Well, it means that you're going to drop your bandwidth by about 30 to 40%. So if you're going at like a 400 megabit per second tunnel, you're going to lose about 40 to 50 megabits on that. So depending on what you're doing, that might be a problem, but it might not, right? You can TLS everything. That's fine. Great. So now everything's got TLS on it. You encrypt it, the applications. Like all the data is encrypted as it transmits, and each side encrypts and decrypts. Well, that's a great idea for some things, right? We all use that, hopefully, for our SIP transmissions. But if we don't, then there are some caveats. Let's go back to Kafka again. Kafka is I think it runs on Java 9 now. Anyway, the one we were using at the time had like a Java 8 implementation. The Java 8 SSL library is just brutally slow when it comes to decrypting. It's just crushingly bad at it. So the throughput overhead from Kafka went from 140,000 messages a second to something like 14,000 messages a second. So a 10x reduction using encryption built into that. So that wasn't an option, right? We can't have a 10x reduction in that data backing store just by using encryption. So we had to find a way around that. That's where you might move to something like the overhead of the IPsec connections or set up like point-to-point VMs between the machines. The point is, this is the kind of thing you got to think about. Everything must be encrypted all the time because at some point someone will be between you and what you're trying to do, and you're just throwing sensitive traffic over the internet hoping that no one's going to see it. And that just can't be done. Particularly, I think the GDPR was a nice, well, not nice, but it was when it came about, it really forced a lot of these conversations to come out of the open of like, are we doing best practices all the time? And if you're starting something new, I would say just start with GDPR compliance immediately. If you have something that already exists, you need to get that. Harder to retrofit, but do take a look at it. And lastly, there's some cloud-based forensics. I would recommend going to look at Netflix. Netflix has a lot of tools for doing cloud-based forensics. They publish a lot of open source talks and tooling about how to look at virtual machines if they've been compromised. I don't know who's compromising Netflix machines or like how much, like what they're doing there. I assume they want to watch like, Game of Thrones or something. They're going to do that. But I know a guy who works over there, and he says it's a big part of the organization is dealing with how do you freeze a virtual machine once you know an attack has happened. And what's nice is that you don't have to tear down like an entire physical box. They don't have access to like your entire network. If someone gets into one container or one virtual machine, assuming you've built your architecture correctly, they're pretty much isolated to that one machine. They can't get to the rest of the network. So you're like, okay, what you do is you just stop and freeze that VM, take a snapshot of it, you then kind of put that in cold storage, and they actually have an entire like other part of the cloud you can spin it up in. It's isolated, that they can do then forensics on it. They can actually look at the non-volatile memory. They've talked to AWS supports all of this, being able to like freeze an exact copy of that machine as it is, and move it over, and do a lot of that work. And so I would say go take a look at Netflix's tooling on this if you're interested in the cloud security aspect, because eventually you might need that as well. Talked about a lot of this kind of stuff, so. I was saying I think really the best way to do this is to use the best of both worlds, right? You have some services you're going to want to run co-located, maybe high database traffic, things that you really want to have tight control over, but then have one of your standby databases up in the cloud somewhere, right, as a fallback. maybe your performance will go down a little bit, right? Maybe the latency is a little bit higher, but you'll still be alive, things will still work. Put things in the right spot, right? Put high bandwidth things in the correct provider, put high input in the correct provider. Make sure that you don't just lock yourself into one vendor. Use everything that's out there. I would say just like one piece of advice is take a look at all the providers, use the best one for your situation, and yeah, and best of luck. So again, I'm Evan McGee. I'm CTO over at SignalWire. You can reach me on Twitter or Instagram if you want to see pictures of my kids. And yeah, if there's any questions, let me know. Thanks so much.